Hi everyone, okay, we're back for the second lesson in our Pythagorean theorem unit. Today we're going to be looking at more on squares, actually squares and cubes, but also extend to something that's new, I guess. It's what we call square roots and cube roots. What we're doing today is we're going to try to evaluate and estimate. Okay, now before we go on to evaluate and estimate, I just want to quickly show you what the relationship is between perfect squares and perfect cubes with the square roots and cube roots. Okay, so first of all, I'm going to write this. Okay, we're going to have some writing to do here. Okay, so first of all, 25 is a perfect square. We know that, and this is because is a perfect square because 5 times 5 is 25, right? So we have two of the same numbers multiplied together, and the end result is a perfect square. Now, of course, we have a notation to show this. We say that 5 squared is 25. Okay, so this is like kind of going forward. Now, if you go backwards, okay, so we're doing the opposite kind of operation here. It's like multiplying, then there's dividing, there's adding, and then there's subtracting. Okay, so we have perfect squares, we have what is the opposite of perfect square, and we call that the square root. So 25 is a perfect square because 5 squared is 25. We then say that 5 is the square root of 25. Okay, and again, because of the same reason, because 5 times 5 is 25. So basically, when we're looking at the square root of a number, we're looking at, or we are thinking about what multiply itself will give us that particular number. So in this case, we're looking at which two numbers, or which number when you multiply itself, it gives us 25. And that number would be 5. So we say that the square root of 25 is 5. And of course, we have a notation for that. This would be the square root, that's the square root symbol, square root of 25, this is equal to 5. Okay, similarly, we can say the same thing about perfect cubes. So then we say that 8 is a perfect cube. And because, like before, 2 times 2 times 2 is 8. Okay, again, we're looking at multiplying. We're trying to multiply one number by itself 3 times. And that result, 8, it would be a perfect cube. And again, we saw this before. The notation for this would be 2 cubed, and that is 8. So similarly, with the square root, we could say that the square root, so these two go together, and these two go together. The cube root, okay, the cube root, because we are looking at opposite of perfect cube. So we're looking at the cube root, okay? The cube root of 8 is 2. And again, because of the same thing over here. Because 2 times 2 times 2 is 8. So when you're thinking about the cube root, you're thinking about what number multiplied by itself 3 times will give me that result, 8. And this kind of becomes a number sense thing. Okay, once you do more, you kind of get the hang of it. Maybe at first it will be challenging, but we'll see. Okay, the notation for this is similar to square root. We have the root symbol, the radical symbol, and then we put a little 3 here, okay, to denote that it's a cube root. If it's a square root, we don't put a number 2 here. I mean, technically you could if you want to, but in the math row, we just say that if it's a square root, we don't put any number there. Okay, but if it's a cube root, we put a 3 there to denote that it's it's the cube. The cube root of 8 would equal to 2. Okay, so this is how the square root and perfect squares, the cube root and the perfect cubes, how they are related. Okay, they're basically, it's really the same thing, but it kind of like thinking backwards. Okay, thinking backwards. Okay, so you make sure you understand how they are related. before we actually go on to the examples of evaluating, okay? Because you kind of know what that means, you know, what perfect cube means, or sorry, what a square root means and what a cube root means first. Okay, so if you're okay with this, then I'm going to show you an example, okay? So let's say we want to figure out, well, actually, you know what? I'm gonna say, here's the question. I'm gonna say, is 216 a perfect square or a perfect cube? Or neither? Okay, so I think we saw this last time. To figure out if it's a perfect square or a perfect cube or not, what we do is we take 216 and we do the factor tree. Okay, we do prime factorization. So you try to break 216 down into its prime factors. Okay, so 216, we can divide both 216 by 4, and this will give us 216 divided by 4 give us 54. Okay, 4 is, well, that's clear. 2 times 2 is 4. Okay, so these two numbers, the 2's, they are prime numbers. So then again, that will be the end of these branches. 54 can be broken into 9 times 6. 9 times 6 is 54. And 9 can be broken into 3 and 3, right? 3 times 3. And again, 3 is a prime number, so we will end right there. And for 6, this is 2 times 3. Okay, so then we have reached the end of our factor tree, I guess. So we can rewrite 216 as 2 times 2 times 3 times 3 times 2 times 3. And again, we can rewrite this in the exponential form. We see that we have 1, 2, 3 2's. So this is 2 cubed times, we have 1, 2, 3 3's. So 3 cubed. Okay, so from last time, we know that it would be a perfect square if we can break we can split these numbers into 2 equal groups. So let's see if we can do that, okay? 216 is equal to, so we're looking at 2 equal groups. Is that possible? So I see that I have 3 2's and 3 3's. I mean, again, I can tell from here, I got 3 2's and 3 3's. Now, can I split 3 2's evenly in 2 equal brackets? Well, unfortunately, we can't. Okay, so 216, we cannot put its factors in 2 equal set of brackets. So we know that 216 will not be a perfect square. Okay, so 216 is not a perfect, because we can't fit it into 2 equal brackets. I mean, you can put 1 2 here and 1 2 here, but you got one extra 2. No matter where you place it, let's say we put it here, but we don't have any more 2's to put into the second set of brackets. So then, not a perfect square. Okay, not a perfect square. Okay, we can we can do something similar with a perfect cube. Okay, so 216. So instead of 2 set of equal brackets, we want to put it into 3 equal set of equal brackets, I guess. So now again, we got 3 2's. So first of all, I can put 1 2 in each set of brackets. There. Once I do that, I run out of 2's. So, well, that's perfect, because then I have 1 2 in each set of brackets, okay? And then we go on to the next number, 3. So again, I have 3 3's. That means I can put 1 3 in each set of brackets. So 2 times 3, 2 times 3, and 2 times 3. Well, that's perfect. This is a perfect cube because I can actually put all its prime factors in 3 equal brackets. Okay, so this is a perfect cube. Okay, now the question is, what is the cube root of 216 then? Okay, so I guess now the question is, well, you know, to answer the question, yes, 216 is a perfect cube. Okay, but now I guess the follow-up question then is, what is the cube root of 216? Well, if you look at this is 2 times 3, which is 6. So this can be rewritten as 6 times 2 times 3 is 6, times 2 times 3 is 6. So what that means, it's like this, right? 2 times 2 times 2 is 8. This is 6 times 6 times 6 is 216. Therefore, the cube root of 216 will be 6. Okay, because 6 times 6 times 6 is 216. So again, this is how you evaluate perfect cubes and perfect squares, actually. So whatever you see, however you can split them in among the equal brackets, whatever product you get, so whatever you multiply to inside the brackets will be the cube root, or it will be the square root. Okay, in this case, because it's 3 equal brackets, it's a cube root. If it's 2 equal brackets, then it would be square root. Okay, hopefully that's not too difficult for you to understand. Let's see. Maybe I'll do one more example, okay? Maybe I'll do one more example. And I'll do this one quickly here. Evaluate, let's say, the square root of, what do we have here? Why don't we try 144? Okay, so then what you do, again, is you take 144, you split, or you do the factor tree for that. This definitely can be divided by 2, so 2 times 72, that's a prime. For 72, we can do 8 times 9. 8 is 4 times 2, that's a prime number. 4 is 2 times 2. 9 is 3 times 3. Okay, so 144 is, or can be rewritten as 2 to the power of 4. That's 1, 2, 3, 4 2's times 2 3's. Okay, 1, 2. So then, because we're evaluating the square root, so then we try to see if we can put into 2 equal set of brackets. Okay, so from here, I see that I have 4 2's, so I can put 2 2's in each set of brackets. I have 2 3's, which means I just need to put 1 3 in each set of brackets. Done. This is 2 equal, 2 set of equal brackets. So this is perfect. This is definitely a perfect square root. It's a perfect square. So then this is 2 times 2 times 3 is 12. So this is 12 times 12, which means the square root of 144 is 12. Okay. Okay. Hopefully that that will help you to understand. Okay. Now that's evaluating. Now next we are going to look at how we estimate, because not all numbers are perfect cubes nor are perfect squares, and therefore we cannot always get an exact value when we take the square root or cube root. So here's another example. We want to estimate square root of, let's say, I don't know, 32. Okay, so think about it. I need a water break, so I'll come back. You think about it, okay? All right, I hope you give it a thought. Now I'm back from my water break. Let's carry on with the estimate of square root of 32. So when we estimate, what we do is we kind of look at the number line, okay? We want to see where 32 is situated. Now, because we're looking at 32 and we're taking the square root, what I need to think about is, well, what's the closest perfect square that is just below 32, and what is the closest perfect square that is just above 32? Now, I know that 5 squared is 25. And I know that 6 squared is 36. Now, 32 is in between 25 and 36. And therefore, I know that the square root of 32 will be 5 point something. Okay, it will be between 5 and 6, because the square root of 25 would be 5, and the square root of 36 would then be 6. But we're looking at a number in between 25 and 36. So then I know that the square root of 32 will be in between 5 and 6, so 5 point something. Okay, now the question is, well, 5 point what, right? It's 5 point something, but what is it? Okay, so what we do is we are going to draw this number line right here. Here's 25. 26, 7, 8, 9, 30, 31, 32 here. 32, 34, 35, 33, 34, 35, 36. Okay, so here is our number line. Okay, so well, I know this is going to be 5 point something. Okay, now the question is 5 point what? Okay, now what we can do is we can look at 32 as, you know, where it is between 25 and 36 relatively. Now you can think of this from here to here as the total distance. Then here's 32. So this is kind of, if you go from here to here, well, or from here to here, this 32 would be around 2/3, right? 2/3 of a way from 25 to 36. Roughly speaking, right? Around 2/3 of a way from 25 to 36. So then what I'm going to do is I'm going to estimate root 32 would be, well, this probably will be close to 5.6 because it's about 2/3 of a way. And we know that 2/3 would be 0.66 repeating. So, I mean, if you want, you can guess that it could be 5.7. That's fine. But I'm going to go ahead and say 5.6, okay? And we can always check. And if it's close, well, that's perfect. If it's not that close, we can always improve on our estimation, right? So when we do check, we just go 5.6 times 5.6 and see what we get, okay? So 6 times 6 is 36. Put a 3 here. 6 times 5 is 30. 30 plus 3 is 33. Then we have 5 times 6, which is 30. Put a 3 here. 5 times 5 is 25. Plus 3 is 28. Add them together. That's 6. That's 3. That's 1. And that's 3. 2 decimal places. So 31.36. I would say this is a pretty accurate estimate. Okay, I would say this is actually pretty good. I mean, if this value is way below 32, let's say maybe it was equal to 30, then we could probably, you know, improve our estimate by, let's say, 5.7 because 5.6 would be way below. But I think 31.36, this is not a bad estimate of what square root of 32 is. Okay, so I would say that's it. Okay, I will do one more example, and then I'll end right here. Okay. I kind of run out of room. I'm gonna put it to the side. I guess you can write on a piece of paper. I'm sure you write smaller than I did here. Anyways, let's do another example. Let's say the square root of, let's try, what should we try here? Maybe we will try 56. Okay, square root of 56. So again, the first step is we need to think about which two perfect squares are closest to 56. Okay, one below and one above. Okay, now I do know 7 squared is 49, and I know 8 squared is 64, and 56 is definitely in between 49 and 64. Okay, so then from here I'm going to draw a number line, starting with 49, 50, 51, 2, 3, 4, 5, 56 right here, 7, 8, 9, 60, 61, 62, 63, 64. So here's 64. Okay, so now 56 is actually pretty much in the middle. Hey, we can actually count. That's 1, 2, 3, 4, 5, 6, 7. 7 away. 1, 2, 3, 4, 5, 6, 7, 8 away. So close to halfway, but not quite. Okay, close to halfway, but not quite. Okay, so now 56, square root of 56. So the square root of 56 would be 7 point something. And that is because, again, 7 squared is 49. So we know that square root of 56 will be bigger than 7. And we know that 8 squared is 64. So we know that square root of 56 would be less than 8 because square root of 64 is 8. Okay, so this would be 7 point something. Now the question is, again, 7 point what? And we just saw that earlier, 56 is almost halfway between 49 and 64. So you know what? I'm just going to go ahead and guess 7 point... I don't know. What should I guess this time? I want to say 7.4. But I kind of want to say 7.5 as well. You know what? I'm going to say 7.4 first and see how close it is. or how off it is, I guess. We'll see. We'll find out. So 4 times 4 is 16. With the 1 here, 4 times 7 is 28. Plus 1 is 29. 7 times 4 is 28. Put an 8 there and a 2. 7 times 7 is 49. Plus 1 is 51. So that's 6. This will be 7. That's 2 plus 1. 7. 9 plus 8 is 17. So put a 1 here. 1 plus 2 plus 1 is 4. And a 5 here. And 2 decimal places. 54.76. Not that great, I suppose. So in that case, a little bit off. So then I would say 7.5. Okay, I would say 7.5. And I will quickly check what I get if I multiply 7.5 by itself. Okay, so I'll quickly multiply this. That's 25, 37. 7 times 5 is 35. 49 plus 3 is 49 plus 52. So this will be 5, 2, and a 6 and a 5. That's 2 decimal places. 56.25. So for sure, this is a better estimate. Okay, 7.5. So yeah, so we try 7.4 first. Not that close. It's not too bad, but it could be better. So I try just 1 decimal place higher. I try 7.5, and you can see it's a much better estimate than what 7.4 gave us. Okay, so that's it for this lesson. If you have any questions, do let me know. Please finish the worksheet, the rest of the handouts, I guess. The level 3 questions, the 3-star questions, some could be quite challenging. Give it a try. Okay, but for sure, definitely finish the first 7 questions. Okay, and try to do this without calculator, and that would be awesome. To develop your number sense. All right, that's it for today. Thank you for watching. Goodbye.